Guys, welcome to today's class. Today we are going to be looking at two theorems. Remember, 2 days ago we did something on that angle at the center, angle that a chord sustained at the center will be twice the angle is sustained at the circumference. And yesterday we did something on that angle of the same segment are all equal, or angle subtended at the circumference by the same chord, they are all equal. And we also proved that. So today we're going to be looking at two theorems, the third and the fourth theorem. The first theorem we are going to be looking at today says that angle subtended by the diameter is a right angle. Angle subtended at the diameter. Remember, to also prove this, we just make use of that first theorem that angle at this. Let's say this is the diameter. This is right. If this is the diameter, any angle it sustains at the circumference will be a right angle. Any angle this sustains at the circumference will be a right angle. Why? Because it sustains a straight line, right? Let's say this is the chord, right? What it sustains at the center is 180 degrees. So we're having that here is 180 degrees. This is 180 degrees, right? Definitely what it sustains will be what? A right angle. A right angle. Also here is 180 degrees. So what it will sustain here is what? A right angle. So any angle that the diameter sustains must be equal to 90 degrees. Right angle means it's 90 degrees. That's what it means. Right angle means it's 90 degrees. So that is the third theorem, that angle sustained by a diameter is a right angle. Angle sustained by a diameter is a right angle. Now we'll go back to the fourth theorem. The fourth theorem states that the opposite angle of a cyclic quadrilateral, you can say that it is supplementary, or they sum up to 180 degrees. Let me show you something. A cyclic quadrilateral means a quadrilateral that is bounded in a circle, right? A quadrilateral means a shape of 4 sides, like a square, a rectangle, or trapezoid, any shape that has 4 sides that is bounded within a circle, that the opposite angles will definitely sum up to give you 180 degrees. Let's just have a rough one. You can just have something like this, right? What it means that if I have x, let's say I have a here, degree, and I have b degrees here. Let's also say I have x degree and also have y degree here. What this theorem first states that a degrees plus b degrees will give me equal to 180 degrees. Also, x degrees plus y degrees will give me equal to 180 degrees. So whatever I have, if I add this plus this, it will give me 180. If I also add this and this, because they are opposite, to give me 180 degrees. Why is it so? Why is it so? Now let me show you why it's so. Because this angle right here, let's say this angle sustains something. Let's say this is the center of the circle, right? This angle sustains something here and here, right? Remember, there's a chord here, for instance. So what I have here, this will sustain this at the center, right? What I have here will be 2x here, and what I have here, this x will sustain 2x here, and this y will sustain 2y here. Is that okay? So you can see that 2x plus 2y is equal to 360 degrees, right? So I can clean this, right? Yes. So I have that 2x plus 2y is equal to angle at a point or angle of a circle, which is what? 360 degrees. So I have that 2 bracket x plus y is equal to 360. I can divide both sides by 2. This 360 cancel by 2 will give me 180 degrees. So I have that x plus y is equal to 180 degrees. I can also do that same thing for the A and B. Let me just clean this a bit. I'll still do it for the A and B so that we'll see how it goes. What you just need to know is that anytime you sum up the opposite angles in a cyclic quadrilateral, it will give you 180 degrees. So if I have this, for instance, let's say this is the center of the circle. That means this A degrees will sustain 2A here, while this B degrees will sustain 2B degrees here, right? So I have that 2A plus 2B is equal to 360, which is angle at a point, angle within a circle, right? So I can factor out my 2. I have A plus B, 2 bracket A plus B is equal to 360. When I divide both sides by 2, this will cancel this, and I'll have 180 here. I have 180 degrees here. It means that A plus B is equal to 180 degrees. This proves that any opposite side of a cyclic quadrilateral will give you equal to 180 degrees. You can just use this to solve anything you want to solve, and just know that if it is subtended by the diameter, then it is 90 degrees on the circumference. Then if it's a cyclic quadrilateral, the sum of the two opposite sides will give you 180 degrees. I ensure you do your assignment and invite your classmates for tomorrow class. Have a very nice day.